Hello students, good morning everybody. Today we present in the chemistry class with the chapter P block elements. My dear children, you know in the periodic table there are 4 blocks S, P, D and F. So the present chapter is P block elements. Now students, just you see the periodic table here. Group 18, Group 3 to 10 transition elements, and Group 3 to 12 actually 10 transition elements, and Group 13 to Group 18 P block elements. Group 13 to Group 18 students P block elements. And my dear children, you know that Group 18 inert gas, that is they known as the noble gas. But our study material in this chapter, that is P block element, and the P block elements general configuration just you are seeing here NS2NP126, NS2NP126, and the electronic configuration of S block, D block, F block already you have learned in standard 11. And in standard 11, the P-block elements group 13 and group 14, my dear children, you have learned. In standard 12, we have to study group 15, group 16, group 17 and group 18. Group 15, that is P-block elements and nitrogen family, and group 16 oxygen family, group 17 halogen family, and group 18 inert gas, that is noble gas family. Just you are seeing here group 13, 14, 15, 16, 17, 18 P block elements. Now students, group 13 and 14, I told you that already we have completed in standard 11, and group 15, 16, 17, 18 our study material in standard 12. Introduction, the P block elements. The P block elements are placed in groups 13 to group 18. This is the first thing. And first of all, we have to know what is P block element. My dear students, P block elements are the elements where the last electron enters to the p orbital. Last electron enters to the p orbital. So first of all, we should know the definition of the P block elements. What is P block elements? P block element is the element where the last electron enters to the p orbital, and it includes the group 13 to 18. General electronic configuration is Ns2Np126. Again I am repeating here, Ns2Np126. The groups included in the syllabus are 15, 16, 17 and 18, my dear children. So, now which group we have to study? Repeat? Yes, very good students. 15, 16, 17 and 18. Just now I discussed 15 groups, family members. The first element is nitrogen. Oxygen is the first member of group 16. And fluorine is the first member of group 17. And helium is the first member of group 18. So first of all, what we have learned here? P block elements definition, and which groups include in the P block element we have learned. What is the electronic configuration, my dear children, you have learned. And which groups are included in your syllabus, group 15, 16, 17 and 18. Now children, group 13 boron family, group 14 carbon family, group 15 nitrogen family, group 16 oxygen family, group 17 fluorine family, and group 18 noble gas family members. So first of all family members of all groups 15 to 18 we should know. Nitrogen, phosphorus, arsenic, antimony and bismuth. These included in group 15. Group 16, oxygen, sulfur, selenium, tellurium and polonium. Group 17, fluorine, chlorine, bromine, iodine and astatine. And group 18, that is helium, argon, krypton, xenon and radon. So first you should know the family members of each group 15 to 18. And students, one thing I am telling you, very important things. In the P block elements, there are three types elements: metals, metalloids and non-metals. And I know that you know what is metal, what is metalloids. Metalloids are the elements which have both properties like as the metal and the non-metals, metal and non-metals. So one question arises, in which block of the periodic table contain metal, metalloids and non-metal? Answer is the P block element. My dear children, and very important chapter and maximum question students, do you know in this chapter the question is coming the reasoning question. Now I am going to the group 15 elements. Nitrogen family. Just to see group 15 elements, nitrogen family. Configuration is NS2, NP3. NS2 and NP3. The elements of group 15 are nitrogen, phosphorus, arsenic, antimony and bismuth. In nitrogen, we have to study N2, HNO3 and NH3. And oxoacid of nitrogen. Oxoacid of nitrogen, that is HNO2, HNO3. In phosphorus, we have to study PCl3, PCl5, PH3 and oxoacids of phosphorus, that is H3PO4, H3PO2, etc. Now this table is very important, and you have seen in the NCERT book, the table is given here, and from the table everything you have to know. Nitrogen symbol, phosphorus P, arsenic S, antimony Sb and bismuth Bi. Atomic number, nitrogen 7, phosphorus 15, arsenic 33, antimony 51 and bismuth 83. Configuration, my dear children, I told you have to write the configuration of each element in the form of inert gas. So for nitrogen, the configuration: helium 2s2 2p3, phosphorus 3s2, neon 3s2 3p3, arsenic, argon 3d10 4s2 4p3, antimony, krypton 4d10 5s2 5p3 and bismuth, xenon 5d10, xenon 54 5d10, so 64, 6s2 66. Xenon will be here. Okay, so from this thing we can write the electronic configuration of nitrogen, phosphorus, arsenic, antimony and bismuth. So what is the electronic configuration of bismuth, my dear children? There will be the xenon 4f14, 5d10, 6s2 and 6p3. 6s2 and 6p3. Now students, another thing, all group 15 elements tend to follow the general periodic tense. Which periodic tense we have to study? First of all, electronegativity. Electronegativity, my dear children, that it decreases down the group. It decreases down the groups. First of all, first properties that we have to know, on moving down the group, what is happening for the electronegativity? Electronegativity decreases down the group. Next is ionization enthalpy. What is ionization enthalpy, my dear children? Ionization enthalpy is the energy which is used to release the electron from the isolated gaseous atom. And when we move from top to bottom, You know, my dear children, atomic size is increasing, metallic character is increasing, so ionization enthalpy is decreasing. So ionization enthalpy here decreasing. Now, atomic radii, on moving down the group, it is increasing. Next, electron's affinity. What is electron affinity? It is the ability of the atom to accept an electron. Again, I am repeating, what is electron affinity? It is the ability of the atom to accept an electron. So, electron affinity also is decreasing on moving down the group. Now, melting point. What is melting point? It is the amount of energy required. It is the amount of energy required to break bonds to change a solid phase substance to a liquid phase, and melting point increases going down the group. Next, my dear children, boiling point. Boiling point is the amount of energy required to break bonds to change the liquid phase to the solid, to the gaseous phase, liquid to gas, and it increasing going down the group. That is, melting point is increasing, boiling point is increasing. Next, the allotropes. Allotropes means nitrogen, name of the allotropes, alpha nitrogen, cubic crystals, beta nitrogen, hexagonal crystalline structure, and phosphorus, maximum, minimum allotropes shown by nitrogen but maximum in other elements, but phosphorus, white phosphorus, red phosphorus and black phosphorus, arsenic, yellow, black and grey metallic, antimony, yellow from metallic, explosive, bismuth, no allotropes. Now students, up to this, the physical properties of the p block elements for today, and next day we will discuss the chemical properties of the 15 group elements. Thank you. Have a nice day.